Hello, this is Jose Luis here at Parametric Camp, and welcome to this bonus video in the Advanced Development in Grasshopper playlist. So in this one, what I wanted to try is this new thing that was presented to me very recently, which is Grasshopper Async Components, a project that was developed by the Speckle Systems folks, and which is a project that allows you, it's basically a template that allows you to develop native components that behave asynchronously. So for example, if you have a very fat component that does a very heavy operation, you can develop it in a way that doesn't block Grasshopper, that doesn't block Rhino, and that while it's doing its computation, you can still work around, you can do things, etc., etc. So for example, I implemented this one called a synchronous for loop, which is basically a for loop that runs however many iterations you want. It does nothing, it just runs a very long for loop. But if you do enough, like for example, this is 100 million times, it will actually take a while. So you can see that the component is calculating, but it's not blocking, it's not outputting anything, and whenever it's done, it just outputs the amount of iterations it has gone through. And I can now change this, and you can see that I can move around, I could do things, and the result will not update until it finishes with the calculations, which is a very nice feature. So in this video, I would like to show you how you have to change slightly the way you create your native Grasshopper components so that they can work asynchronously. If you have any part of your plugin that has very heavy operations, this is definitely a nice feature to have so that you make the experience for people to use Grasshopper much more fluid and nice. All right, let's talking and more async component development. So let's get started. So how are we going to do this? Well, Grasshopper 1.0 does not let you do this out of the box. But there are ways to do this by basically hacking a little bit the way native Grasshoppers are done. And this is what the people at Speckle Systems have done. What they have done is that they have created a project that is called the Grasshopper Async component, in which they're basically wrapping in a way the standard code that we use for developing native components, and they're wrapping it inside of a larger set of code that allows us to use that same code or a very similar code, if you will, but wrap it inside of additional code that makes it work in a way that doesn't block the natural flow of data or the runtime of Grasshopper. So this is what you can see here in the example, and they have a GitHub repo with both the wrapper code for the components and example files. They also point to this companion blog post that explains how do you have to develop such components and what things do you need to keep in mind when doing this. I have found this blog post very helpful, with the only exception that this blog post was written in 2020 and I am recording this video in 2023, which means that I actually found that this example here with these names and collect data and the signature of these functions are not valid anymore for the more updated versions that they have recently published. So don't worry too much about that, because I'm going to explain to you in this video how do you need to implement this as of March 2023. But if you're watching this in the distant future, then some small things may have changed by the time you implement this. Or if you're watching this in the far distant future, I believe Grasshopper 2, whenever it releases, will incorporate this function out of the box. So maybe doing async components using the Speckle template might be obsolete at this point in the future. Okay, if that's the case, you might find examples of how to do asynchronous or non-thread blocking components here in the playlist in our channel. Okay, so the first thing that we're going to do is we're going to clone the code. So you're going to go to the Speckles repo. There will be a link in the description of this video. There might be a card popping up in the corner with where you can find this, and clone this however you feel. You can just download the zip and extract it on your desktop. You can use Git to clone the repo. I'm in the process of recording a Git playlist right now. There might be a card somewhere, or just probably look through the channel. There might be a Git playlist somewhere here, okay? And I've already done that before. I have extracted that, and what I have is a Visual Studio project that contains the wrapper code and a demo of how to do that. This project looks something like this. So if I open it in Visual Studio, what you can see is that I have two distinct projects. One of them is the wrapper code. So this is going to be the Grasshopper async component. Is going to be the extension of the Grasshopper component class that we typically use to create components. What this means is that when we want to create an async component, instead of inheriting, I don't know how to say that, from Grasshopper component interface or class, we will inherit from the Grasshopper async component. And I will explain how to do that, right? And it also has the template code for this other abstract class called the worker instance, which is this instance that gets threaded and that is doing the heavy duty computation and that is reporting progress to the main one that is displaying that progress on the Grasshopper component. Okay, I will also explain how that works. Now, after that, something that you can do is you can go to the actual Grasshopper async component demo. This is basically a tiny plugin that has two components, a useless cycles, I actually haven't tried this one, or the prime calculator, which basically they do have a full implementation of everything that you need to do in order to implement this async logic. Okay, you can look through it. I'm not going to do it in the video because I'm actually going to show you how to do it. But one thing that you can do just to try and see if things work out is you can build this plugin. You can build the async component demo as a solution. You can see that that got built on my system into obj debug component blah 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 whatever. So basically this folder Grasshopper component demo bin debug 48 whatever. So now I have the GHA file which I have added to my Grasshopper developer settings. So now I have the folder here with the Grasshopper async component, which means that Rhino and Grasshopper are now aware of that plugin. And if I now go to the async samples tab, you can see that I have here the sample async component. So if I now, for example, put a slider with a very, very, very large number, you know, and no, sorry, I want a slider. So if I do a slider with a very large number, you can see that the thing starts calculating, and you can see that while it's calculating, my Grasshopper is responsive. I can do other things, I can drop a slider, you know, and the thing is still computing. I can even right click and cancel the operation, like, oh, that's going to take too long, and then just reduce the number, and then hopefully this is going to be much faster now. Faster, yes. And hopefully this is going to be, oh, not much faster. Well, but it's doing its thing. Let me crank this down a little. There you go. 60,000. I don't know. Well, it's taking a lot, but you can see that it's doing what it's supposed to do. All right. So this is probably the first thing that you want to do to try out that things work and that you have a working example from the repo. And then after that, what you can do now is you can bring in that code to have some of the components in your plugin use this asynchronous logic. I can't believe this still hasn't finished. I'm going to, yeah, so let me just substitute this. I think it's just blocked on some previous calculation. I can't believe it's just taking that long. So let me actually, yes, I think it's somehow, oh, I don't know why it's taking so long. Anyway, this was much faster when I tried before in my computer for some reason. Anyway, so, and the next thing that you want to do is take this code and use it to make some of your components in your plugin asynchronous. Let me show you how I would do that with the plugin that we have been developing, the parametric chem plugin. If you remember from our previous videos in this playlist, we have this Grasshopper plugin that we call the pcam plugin, where we're basically just testing a bunch of stuff. So what I would like to do now is, just as I have folders for every type of category for every category of component. What I'm going to do is that I'm going to right click and add a new folder that I'm going to call async components. All right. Then in here, what I would like to do is, first of all, what I'm going to do is I'm going to bring the code that I need in order to make components asynchronous. But for that, I'm going to go back to the original repo, the repo that said the async component. I'm going to go to the folder that has the worker instance C# file and the Grasshopper async component C# file. I'm going to take those two files, I'm going to copy them, and back in my plugin folder, I'm going to go to asynchronous components and I'm going to paste those two files there in the folder that I just created. Those files are hopefully going to show up here, and now you can see that I have both the async component and the worker available in my project. The only thing that I need to remember is that because I just copy pasted them, they have this namespace called Grasshopper async component, which I can either replace or rename, or I can reuse for my own advantage. Okay, or I can just reuse as it is. The next thing that I would like to do is I'm just going to create a Grasshopper component that is going to perform some kind of very fat and heavy operation. In my case, I'm going to keep it super simple. I'm just going to make a for loop that it's just very, very long, but it does basically nothing. But for loops, if you do millions of iterations, they actually take quite some time to execute. So I'm going to add here a new item, and I'm going to do as I typically do, an empty Grasshopper component for right now, and I'm going to call this for loop. All right, async for loop, and then let me rename this to be consistent with the rest of the I always have component here. I'm going to call this async for loop, async for loop. Async for loop is going to go under pcamp, and the subcategory is going to be asynchronous. All right. Now, the first thing that I need to do is remember how all components inherit from Grasshopper component. Now I do need to change that because I want to inherit from this new wrapper that has all the nice and asynchronous goodies. So what I'm going to do is I'm going to replace this with Grasshopper async component, which is not going to be available because I need to bring in the namespace that this class belongs to. So I'm going to use using and then Grasshopper async component. And when I do that, now all the stuff in this namespace becomes available for me here. All right. So that's the first thing. Then I'm going to walk you through, you can read in the documentation or you can just follow my case. So register inputs and outputs is going to be the same. So I'm still going to use, for example, I'm going to add an integer that is going to be I, and it's going to be iterations, no description, because I'm trying to do this very fast, and item access. All right. And then P manager is going to be add integer parameter, or for example, add string, add text parameter, and that's going to be message, or m, and that's going to be message, and that's going to be no description, and also an it item. Really, what I just want to do this component to do is to just iterate over a very long for loop and then just say, I did this many loop iterations, okay? Now here's where things change a little. Remember that solve instance was this function that we used to retrieve the data from the inputs, do whatever operations we have to do, and then put that back in the outputs. Because if that we now need to eliminate, because we basically only have, because if we did that in one single function, that would be a synchronous thread blocking operation. So what this wrapper, the async component, does is that it gives us a slightly different way to perform those operations in a way that is thread friendly, that it allows us to do it in a separate processor and then deal with the results after the fact. Okay, I'm going to add you can still do your icons, so resources. I'm just going to put the parametric camp icon, and the GUID stays the same. Okay, so you still need a unique identifier. All right. Now, one thing that we can add is that we can add the capacity to cancel the operation if it's taking too long. The way we do that is by doing a public override of the function, one of the functions that the asynchronous component is giving us. That is going to be the append additional menu items, right? Tools strip down to menu, blah, blah, blah. So we do the baseline. And then what we do is to the menu, we want to append an item, and that item is going to be the menu. I want to append the cancel operation, and then I need to specify an event handler. So some function that will run based on some function that will run when I click cancel. I'm going to declare an anonymous function that is going to take two methods. So it's going to take two arguments. And here, what I'm just going to say is that I want to request a cancellation. So whenever someone clicks cancel, I'm going to request a cancellation, which is a function that is part of the asynchronous component. So you can see that if I go press F2, I go to the Grasshopper async component original code. So it's part of that wrapper code that is given to us. All right? Beautiful. And for the most part, when it comes to the standard component, the standard part of the component, this is what we need, okay? Now, as I said, because we don't have the solve instance function anymore, what we need to do is we need to figure out a way to both read the inputs, perform the calculation, and generate the outputs in a way that is not happening on the same thread that regular Grasshopper components do, but in a parallel thread. What the async component framework allows us to do is to use this other template that they call the worker instance. A worker is typically a name that is used in asynchronous programming for all these different processes that you launch in parallel that are happening and then that you manage somehow centrally. You take the inputs and the results from some kind of centralized units. It's a very common term for thread operations or for parallel operations. And what they're basically giving us is a class that we can override with our own parameters to make sure that we do the operations that need to be done for managing those inputs, those outputs, and the actual code. So what I'm going to do then is I'm going to go here and I'm going to create inside of my component so that everything stays a bit more encapsulated. I'm going to create a private class that I'm going to call, for example, for loop worker. All right. And this is going to inherit from the worker instance that is part of the Speckle async component framework. All right. By doing that, what I'm basically doing is I'm taking advantage of all the code that is already here and all the structure that the worker asks me to implement. What does that look like? You can see that I already have an error because this is telling me you need to implement a get data function, you need to implement a set data function, you need to implement a duplicate, you need to implement a do work, you need to implement all this stuff that you have not implemented to have the worker work well. All right, so then let's do one at a time. So first of all, I'm going to declare a construction, so that a constructor for loop worker is going to be equal to just calling the base function with the base constructor with nothing on it. All right, this is just basically a way of initializing the worker. Okay, and then I got one of the requirements done. The next one is going to be what am I going to do? I'm going to do the do work, right? The do work is actually the most important one, which is the one that actually has the whatever algorithm you are trying to do. So for example, public override, and then you can see that it already gives me the suggestion, do work, okay? And you know what? I'm actually going to add them all. So public override, then what else do I need to do? I need to have the get data function. I need to have the set data function, and I need to have the duplicate function, a way of copying itself. So the duplicate function, all right, And you can see that by default, none of them have any code. They just throw exceptions if I run them. So let's start one by one. So let's start with get data. In get data, what we're going to do is we're going to handle the information. We're going to handle picking the information from the component. If you remember, that is akin to what we would do in solve instance, where we would say, can you please give me the stuff that is coming in? We do that from the interface data access. So here we do have the same interface. So it's the same thing. So what I'm going to do is I'm going to define number of iterations -1, and I'm going to say da dot please get the data from the first input in the component, and can you please put it on this variable that I have defined called _it. All right. The only problem that we have right now is that if you remember when we used to do solve instance, because we fetch the data in the same function that we use the data and then we output it, then we were basically good writing all that code inside of the solve instance function. Now we have different functions. We have get data, set data, and do work. So how can we exchange information between the three parts of the three functions? I'm actually going to rewrite this here so that it's a little clearer. The way to do that is by now taking this data and basically storing it as a property of this class. So for example, I'm going to declare a property here that I'm going to call number of iterations, and I'm going to initialize it to -1, all right? When this function gets executed, it reads the amount of iterations and then it saves that in number of iterations. That is so that this value, that is for this value now to become accessible to anyone else in this class, all right? Beautiful. The next thing we want to do is we're going to do some work, which is we're going to perform whatever the calculations. Now, here, what are the calculations that we're going to do? Well, first of all, because we did implement the possibility to cancel, one thing that the Speckle people recommend is that because this is asynchronous, the more you check in your code for whether if the user has canceled, the more the code will be responsive to it. So for example, here what we can do is we can check if the cancellation token, which is a property of the base worker instance, if this cancellation token has been requested for cancellation, then we can just stop the function at all right? Then the next thing that we can probably do is I'm just going to say, I'm going to calculate the result of this, which is going to be -1, and then I'm going to do a for loop when I'm going to say for loop int I equals 0, I is minus equals to the number of iterations, right, I plus plus, and then what we're going to do is we're just going to say the result is going to be that number. I really don't want to do or the square root of that number or the cube of the square root of the number, whatever you want to do. But I just want to do like a really long for loop for the sake of making the CPU run a lot. Now, the user may request at some point to stop this, to stop the thread while the for loop is running, right? So something that we could do is we could say, if this is true, if the cancellation token is like this, then just return. Just stop the for loop and do nothing else, all right? And another thing that we can do is, while the for loop is running, we can update in the component, we can update how far away we are in the calculation process. So something that we can do is we can use the report progress function, which is a function that comes also with the worker, right? So if it comes from, it actually comes here with, and then what we can do is we can say, this is the ID of the worker that I am. So this is so that the thread safe architecture of this framework is able to place the update of the number in the right component. And then you need to tell me how far away in a scale from 0 to 1 you are from finishing this. So in our case, this is going to be I divided by the number of iterations, and one of them has to be a double so that we don't do integer operation, right? And that's it. So, and then once we're done, the way we need to do is we need to take whatever result we have and make sure that it's accessible to set data. So we're going to use the same technique. I'm going to define an integer here, final result is going to be -1 or whatever. And then here, once we have finished going through the whole for loop, what I'm going to do is I'm going to say final result is going to be equal to that value that we've calculated. Okay? And we're done. Now, what the final result, I did an integer, no, it has to be a double, sorry. Now, one thing that the developers, the Speckle people tell us is that we need to remember, once we are done with all the calculations, we need to report from the worker and we need to signal that we are done with calculations. There is a function called done that is passed here to the do work function that we can just call to say, hey, you know what? We're done with this. Can you please output stuff through the output component, right? And then the async component framework will take care of and now executing set data. Set data is going to be taking the data that we're interested in and setting it through the output. In this case, it will be for us final result, which was this instance variable that we created to store the result of the value. Okay. And then here in duplicate, which we need to implement, we just can return like a new instance of the, what is it called? The for loop worker. Yes, like a new empty instance of for loop worker. All right. Okay, are we ready for this? We are not, because one thing that we need to remember as well is that here, whenever we have the async component will always have a worker inside that is who does the work. And we need to initialize that. So there is a property in the async component. Can you see this? It's part of is part of the async component here. Base worker is going to be an instance of that new class for loop worker that we just created. Okay, beautiful. So because I have linked my pcamp with my Rhino, etc., what's going to happen is that as I press build, this is going to get built and my Rhino is going to open a Grasshopper file where I already have my pcamp plugin loaded. If you don't know how to do that, I have videos in this playlist where I talk about how to streamlining your development processes and connecting Visual Studio with Rhino, etc., etc. There should be a video, a card popping up in the corner at some point. So just keep an eye on that. All right. And now I have this file, which is the file that had all the components, right? What I had placed here, this bucket for async components. So if I go to parametric camp, you can see that I have a new tab called async, and this is called the async for. All right. So I'm going to place it in here. I'm going to open up a little bit here, and then ta-da! What? And then I can press it here, and then it's running, it's running. Come on, come on. And yes! All right. And then if I change this value, hopefully it will now calculate like something that is, yeah. So it basically just gives me the number that we have input here. So it's not anything fancy, but because it's a for loop that iterates over 55 million times, it kind of takes a while, all right? So of course, you could use this to generate, I don't know, if you have like a lot of Boolean operations that take a while, or if you have some code that is just doing a lot of operations, but you want to be able to be responsive or to print data while this is happening, this could be a good way for you. It's actually a really nice project. I want to give a shout out from here to the Speckle people. This was a very nice thing to try out, and I could see a lot of components and a lot of development making use of this framework. Thank you very much, folks. And also a friendly reminder, I haven't really looked at the license, but if you use this on your projects, make sure that you are compliant with the license so that you don't, you share that this is part of Grasshopper Async, Speckle systems, etc., etc. So I'm actually going to do that right now myself, and I'm just going to write here, adapted from these people here, okay? Beautiful. All right, so with this, I think this is what I wanted to do. So I think we're good here. Yes, so thank you very much. I thought this was really cool, actually. I hope this was useful for you. If you're watching this in the future, make sure to check if the things are still written the same way and the functions have the same name, etc., etc. And if you're watching this from Grasshopper 2 world, then maybe there's a way to do this natively in Grasshopper at this point in the future. Okay, but in the meantime, have fun with this. Thank you very much, and see you on some other videos here at Parametric Camp. And maybe like this one, maybe subscribe to the channel. I don't know, whatever you like. Okay, thank you very much, and see you in the next video. Bye bye.